Hello viewers, welcome to our YouTube channel Incredible Maths. In this video, we will solve a problem asked in CSIR Net June 2023. This question is asked in part C. The question ID is 704-100. This question is related to the topic integral equations. So we are given the integral equation pi of x equal to lambda integral 0 to pi sin of x plus t pi of t dt, where mu1 less than mu2 be the two real characteristic numbers for the homogeneous integral equation. This one. So lambda 1, lambda 2 are characteristic numbers for this equation, and mu1, mu2 are characteristic numbers for this equation. So that means here we need to find the characteristic values for the two integral equations. So let us take the first integral equation pi of x. So now consider pi of x equal to lambda integral 0 to 2 pi sin of x plus t pi of t dt. So here this one k of x comma t is equal to sin of x plus t. So given this is an homogeneous linear integral equation, so this is of Fredholm integral equation. So the integral equation of the form integral sum a to b k of x comma t pi of t dt. So therefore this is k of x comma t is sin of x plus t. So this can be expanded as is using the formula of sin of a plus b, that is sin a cos b, sin x cos t plus cos x sin t. So this is k of x comma t. So this one can be taken as a1. So this one is a1 and this one is b1 and this one is a2 and this one is b2. So now we need to find the integral characteristic values for the given integral equation. The characteristic equation given by d of lambda equal to 0. So where d of lambda is so 1 minus a11 into lambda minus lambda a12 minus lambda a21 1 minus a22 lambda. So where a11 is given by the formula, so general formula aik is given by integral bi of t ak of t dt. So this one. So therefore a11 is integral. So the limit is 0 to 2 pi a1 of t, that is sin t. a1 of t is sin t into b1 of t. b1 of t is cos t to dt. So this is, so this can be written as 1 by 2 integral 0 to 2 pi sin 2t dt. So integrating, so you get cos 2t by 2, so minus sin 0 to 2 pi, so this is equal to minus 1 by 4. So cos 2t is cos 4 pi, so cos 4 pi minus cos 0, so this will be 0, a11. And similarly a22 is integral 0 to 2 pi to a2 of t. So a2 of t is cos t to b2 of t is sin t. So this is same as a11 integral 0 to 2 pi sin t cos t. So therefore this is equal to 0. So this is similar to a11. So now we will find a12. So a12 is equal to integral 0 to 2 pi b2 of t. So b2 of t is, so this is b2 of t is sin t into a1, that is sin t. So sin t into sin t dt, this is equal to integral 0 to 2 pi sin square t dt. Sin square t can be written as 1 minus cos 2t by 2 integral 0 to 2 pi, this is dt. So this can be written as 1 by 2. Now integrating this, t minus cos 2t by 2, the limit is 0 to 2 pi, so this is equal to 1 by 2. So upper limit 2 pi minus cos 2 pi, cos 2 into 2 pi, that is cos 4 pi. Cos 4 pi is 1 by 2 minus lower limits 0 minus one. Sorry. So here integrating cos, so there is a mistake here. So this would be sine. So sine 4 pi is again 0. So this is 0 and this is also 0. So we get as pi a12 now a21. So a21 is integral 0 to 2 pi b2 of t into a1 of t dt. So b2 this would be a1, sorry, b1 of t into a2 of t. b1 of t, b1 of t is cos t and a2 of t is cos t. So cos square t. So 0 to 2 pi cos square t dt. So this is 1 minus, sorry, 1 plus cos 2t, sorry, this here it is cos square by 2, 0 to 2 pi dt. Again this is same as this a12. So a21 equal to is also pi. So you can verify. So now substitute all these things in that is d of lambda. So now d of lambda is equal to 1 minus lambda into a11. a11 is 0 and similarly a22 is 0 and this is minus lambda pi and this is minus lambda into a21. So now d of lambda equal to 0. So this implies 1 minus lambda square pi square equal to 0. Lambda square pi square equal to 1, lambda square equal to 1 by pi square. So this implies lambda 1 equal to, so there is a condition given on lambda 1 and lambda 2. So lambda 1 is less than lambda 2, therefore so here this one lambda is equal to minus 1 by pi and lambda 2 is equal to plus 1 by pi, since lambda 1 is less than lambda 2. So these two are d eigenvalues or characteristics values for this one. So next we can find the same thing. Okay, so characteristic values for the second integral equation, that is mu of x. Second integral equation is this one, psi of x equal to mu times integral 0 to pi cos of x plus t psi of t dt. Now this k of x comma t is, can expand cos x cos a cos b minus sin a sin b. So we will try find a11. So a11 equal to integral 0 to pi b1 of t. b1 of t is cos t, and into a1 of t. a1 of t is cos t. So cos square t dt. So this can be written as 1 plus cos 2t by 2 integral 0 to pi dt. So now integrate 1 by 2. So t plus sin 2t by 2, the limit is 0 to pi. So this is equal to 1 by 2 pi sin 2 pi is 0 minus, so lower limit, when you substitute lower limit is 0. So this is equal to pi by 2. And when a22, so this is 0 to pi b2 into a2, so you get sin square minus sin square t dt. So this is equal to minus 0 to pi 1 minus cos 2t by 2 into dt. So this is equal to minus 1 by 2 t minus sin 2t by 2, again 0 to pi. So this is equal to minus 1 by 2 into pi. So this is minus pi by 2, a22. So now a12. So a12 is equal to integral 0 to pi b1. This is b1. So this is a1, a2, b1. Sorry, b1, a2, b2. So now we need b1. b1 is cos t, a2 sin t. Sin t cos t dt. So this can be written as 1 by 2 0 to pi sin 2t dt. So when we integrate, get 1 by 2 cos 2t, the limit is 0 to pi. Cos 2 pi is 1 and cos 0 is 1. 1 minus 1 0, therefore, and similarly a21 will also 0. Okay, so we can verify. So now the integral equation d of lambda equal to 0. This is 1 minus lambda into a11. So a11 is pi by 2. This is 0, 0, and this one is 1 minus lambda into a22. a2 is minus pi by 2. So we'll get plus pi by 2 equal to 0. So solving 1 minus lambda into pi by 2 into 1 minus lambda into 1 plus lambda into pi by 2 equal to 0. So here we get lambda into pi by 2 equal to 1, or lambda. So here we can take it as mu. This one is mu. Mu equal to 2 by pi. and here mu is equal to minus 1, so minus 2 by pi. So the condition on mu, so the condition on mu is mu1 less than mu2. So now mu1 less than mu2, so this one mu1 can be taken as minus 2 by pi and mu2 can be taken as 2 by pi. So now we will check the options. So mu is less than mu1 is less than lambda 1, less than lambda 2, less than mu2. So mu1 is what is mu1? So mu1 is minus 2 by pi, and this one lambda 1 is minus 1 by pi, lambda 2 is 1 by pi, and mu2 is 2 by pi. So you check whether this inequality is satisfied. So this is satisfied, therefore A is true. And the second one, lambda 1 is less than mu1, so this is not true. So this is not true. Since A is true, this is not true. So here the modulus is missing. So mu1 minus lambda 1 is equal to mu2 minus lambda 2. So mu1 is minus 2 by pi minus lambda 1 is so this is 1 by pi, and mu2 is, so minus lambda 2 is 1 by pi, so this is correct. And mu1 minus lambda 1 is, this one is 1 by pi, and this is also 1 by pi, so this is equal to 2, so this is wrong. So therefore the correct options for this question is option A and option C. So if you like the current affairs video, you can like and share with your friends, also subscribe our channel. So this video provides a detailed solution for this problem. Okay, thank you.